Look at binomial distribution or expansion, depending what word you use there, and the general term or the general theorem. So let's say we have to distribute or expand this binomial. It's a binomial because there's two terms within the bracket and to the power of 10. I guess the basic way to do it would be to write this binomial and multiply it by itself 10 times till we got to the 10th one. Okay, this is a very, very long process, FOIL, all that stuff. Another way we could use this is a formula, and this formula will tell us, especially if they're asking us for a specific term, because when we expand all this, when you expand a normal binomial just to the power of 2, so you start with two values and you end up with a trinomial. Okay, so if we have 10, there's probably going to be 11 terms in our total expansion, and let's say they ask us for, we want to know what the fifth term is. Okay, well, one of the ways we only know to do that is to expand it. Another thing we can do is we can work with a general formula that will help us find the fifth term. Okay, so I'm going to scroll down here. This is Pascal's triangle, and Pascal's triangle can also be represented with combinations. Okay, so the very first number in Pascal's triangle can also be represented as the first row, so it's 0, C0. And if you were to type that in as a combination, let's see if we can bring it up in our calculator here. Do I remember how to do it? I think I do. There it is. Okay, so here's our combination. If I said 0, 0 equals, boom, it gives us the value of 1, right? And then the next line is 1 C0 and 1 C1. And according to Pascal's triangle, those both equal 1. So let's test it. That equals 1. And let's do it again. And 1 again. Great. And just to make sure, our third one, the third row of Pascal's triangle can be represented using combinations 2C0, 2C1, 2C2. So it's essentially a pattern to build for whatever the term is. And just to prove to you, let's do 2C1. So the middle term should be 2. 2C0. First term should be 1. And then 2C2. Boom. Okay, so I'm definitely not lying to you. It works out great. So what this general term will do will help us find a number, like I said, when there's 11 terms. We could continue building Pascal's triangle. We go 1, 3, 3, 1, right? So this would be a binomial. So say it was a plus b to the power of 0. This would be a plus b to the power of 1. A plus b to the power of 2. And like we said, when it's to the power of 2, there are 3 terms. And this kind of tells you what value to multiply the coefficient by. The next row would be representing a plus b to the power of 3. And if we were to do it to the power of 3, there ends up being 4 terms. Okay, so this is the first, the second, the third, and the fourth term. And we can use combinations to represent this. So the combination is what is helpful. It can tell us what row we're in. 0 is the first one, 1 is the second, 2 is the third. So if we had to go to the number 10, we'd be looking at 11C0, 11C1, 11C2, right? And all of those would be the terms. Another way to do that, instead of building these very long triangles, especially when you get to the 11th row, is to use this formula here, okay? So the n is our exponent, our value of 10. The a is the first term, and the y here would be our b, our second term. So let's essentially just fill it in. It's just
R is if they give it, what give it?
Yeah,
they give it
R is what number are they looking for? So say it was the fifth term, well then we plug the number 5 in there.
But they're saying the general term, so we just...
Yeah, so this is a general formula to find all of them. So I'll show you. We'll build a formula, and we'll pick a couple of them from this row and see how we can find those general terms. So let's build a formula first. Our a value is going to be x, right? And we said n was 10, so we should color code it. N is going to be our exponent, so that's the number 10. We don't know what we're solving for yet, so we're going to leave that open. We're going to call that r. A would be the first term in the binomial, so in this case, that'll be our x value, so that'll be our a. So we replace a with x to the power of n. Well, n is 10, yeah, minus r. We don't know what r is yet. And the y is the b term in our binomial, okay? So times y or b and to the power of r again. So once we've created this formula, the only unknown is the r. So what it's saying is we can solve for any general term in a row, in row 10 specifically, Okay, or sorry, I shouldn't say row 10. It's technically the 11th row. But when we're to the power of 10, we can solve for any of the general terms just using this, instead of expanding either of these all the way down to that row.
And you can't simplify that more, right?
This is about as simplified as it'll get. We'll simplify the number after we plug in a value. So for instance, where I kept repeating the 5th term. So let's say we're looking for the 5th term. So r is equal to the number 5. So we'll plug it in here. You want to try it with your calculator there? Okay. It would essentially be 10, 5, so we have our combination, and x, 10 minus 5, and y to the 5th. Okay.
So 10 combination 5 is 252.
Okay, so 252. 10 minus 5, it's a 5, and y ends up being 5. So this is our term here. Okay, so we can tactically check that, and it's a bit annoying, but I'm going to show you what it means by that in Pascal's triangle. Okay, so the next row in Pascal's triangle, I know it's really hard to see, and maybe actually it'll make more sense. Let's just move everything out and continue Pascal's triangle, otherwise it's going to get very confusing here. I'll try to squeeze it all in. So that's to the power of 3. The next row would be power of 4, so I'm going to quickly build this. Okay, next one would be power of 5. And you can see as I do this how long it kind of takes to continue building this. 1, 6, 15, 20, 15, 6, 1. We're only at 6, and we technically need to go to 10, right? And that's why this formula, this general term, or this general formula is so much easier. 1, 7, 21, 35.
Do you memorize it, or do you?
I'm just adding very quickly in my head. Yes. 21, 7, 1. So then I would have 1, 8, 28. 56, 70, 56. And it's a pattern, right? Once I go up, 56, 28, 8, and 1. And that would be to the power of 8. I still got to go 2 more. 1, 9, 36, 70, 84.
That's not a 9.
That should be a 9. I'm just trying to squeeze in place.
Okay.
It shouldn't be 19, right. You're right. This will be 30, 126, 126. 84, 36, 9, and 1. And I have to squeeze this in again. 1, 10, 9 and 36 should be 45. This will be 90, 120. So see how very ugly this gets. This will become 30 plus 80 is 210. Say that right. This becomes 252. And then 210, 120. 45, 10, and 1. And that's to the power of 10. So let's count our terms. This is technically to our power of 10. And I know it's kind of written very ugly, but this would be the first term, the second term, third term, fourth term, fifth term, and the sixth term. 7, 8, 9, 10. Okay, so there are 11 terms. Did we write this in right? So we have a little error here on the side. So let's check, because I had a little bit of an error when I described this number to you. When I say the 5th term, and the reason I want to show you this, remember how we talked about when we go to the power of 10, there's technically going to be 11 terms, right? When we're using combinations, the first term all the time is technically the kind of the 0 term. Like we did, the next row would be 3, combination 0, 3C1, 3C2, 3C3, okay? So I should have been more direct in my question, okay? When I say the combination of the 5th term, it's technically the 6th term in line, but because of the way the combinations count, the first term would be 0, then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then here's 10. Oh, that's not 9. Should have that right. 9. So because combinations, we have to start with the very first value being 0, my description of the 5th term here is really the combination of 4.
Okay? So when you do 10 to 5, how come we still don't get? We
would have got the 4th term. When we did 10 to 5, that's technically the 6th term in the Pascal's triangle. Okay, and that's where you get your 10C. Whoops. 10. Oh, I gotta note that stuff. I'm just gonna put a line because when I do a circle, it does something. 10C. 5, okay, that should be the number 10. And that's because the very first term is 10C0. So that would be, every time I make a circle, that would be our first term. Our 10C0 is term 1. 10C1 is technically the second term, if we're counting from left to right. Okay, so we just have to keep that in mind. So when I describe the fifth term and we put in the number 5 here, that's the combination 5. It's actually the sixth term when we count all the way through because there are 11 terms. So we have to keep that in mind when we're going through this. But the whole point of this formula right here is so that we don't have to build this giant triangle. We can just very quickly plug these values in, and we know that this number, combination 5, the sixth term in the triangle, would be 252. Our a value would be x to the power 5, y to the power of 5.
Just see what it says.